My name is Yash Kandas and I belong to Group 2 of Melbourne City Campus. And today I'll be starting the presentation of Assessment 2, which is the analysis and report on operating system functioning and security. So these are my group participants. My name is Yash Kandas, and we'll start with the first slide, which is introduction. So introduction, operating system is the spine of computer frameworks. The operating system connects the hardware with the application. So it acts like a middleman between all the applications and all the hardware. So it is a very important component of any computer system or any framework. Uh, Operating system acts as a mediator between the client and the computer equipment, empowering the execution of applications and overseeing assignments such as memory allotment, repair planning, and record administration. The reason of this report is to analyze, compare, and give suggestions on different angles of working frameworks and centering on their structure, highlights, and other things. We will also compare other operating systems like Windows, Unix, and Linux. Moving on, our second slide has computer system overview. So a computer framework is composed of a few interrelated components such as CPU, memory, input, output, gadgets, and capacity, printers, and all of those things. The CPU performs computations and forms information, whereas memory, both unstable like SLAM and non-volatile like perform stores information. The I/O, that is input-output gadgets, permit the computer to connect with the outside environments. With the input devices such as keyboard and mouse, we can put our queries or our data into the computer, and with the output devices like a printer and screen, we can get information from the computer. And moving to our next slide, which is operating system overview. So working frameworks have advanced essentially over the decades, getting to be more advanced, and it is indispensably to computing. So as the time passes, the computers and operating systems are getting more advanced and faster and more able to do complex algorithms or solve complex questions or equations. Their key capacities incorporate overseeing equipment assets, encouraging client interaction through a client interface, executing and planning forms, taking care of memory administration, and guaranteeing security and record administration. So these are some of the points that operating systems do, how they connect with the outside world, and many things. So now my friend will move on with the other slides. Thanks for listening to me. This was Yash Kandas.
Hi, my name is Satwinder, and I'll start with the processes. A process is a running instance of a program actively executed by the CPU. The operating system tracks each process using a structure called the process control block or PCB. The PCB is a crucial because it contains all the necessary information about the process, like its current state, whether it's running ready or waiting for the resource, along with the CPU register content, memory allocation, and scheduling information. Managing processes involve overseeing the entire life cycle from creation to termination. In UNIX system, processes are typically created through the forking, where a new process called a child inherits many traits from its parent. UNIX also uses signals to control processes. So next one I would like to talk about is the threads. Threads are the smaller independent units of execution while within a single process. Unlike the processes which have separate memory spaces, threads shares the same memory and resources within a process. This shared environment allows threads to run simultaneously, significantly improving the performance and responsiveness of applications, especially on multi-core processors. In such systems, different threads of a single process can be executed on different cores at the same time, optimizing CPU usage and speeding up processing. So the next one is about the uniprocessor scheduling, which is about deciding the order in which processes get access to the CPU. Several scheduling policies are commonly used. First come, first serve, or FCFS, executes processes in the order they arrive, but this can cause inefficiencies like the convey effect, where short processes are delayed by a longer one. Round robin gives each process a fixed time slice, ensuring fairness but potentially reducing the performance due to the frequent context switching. Sorry. Shortest process next schedules the shortest task first, reducing the wait times but risks starvation for longer processes. Shortest remaining time is the preemptive version of this, which interrupts longer task if shorter ones arrives. Again, risking starvation. Finally, the high response ratio next balances fairness by considering both wait time and execution time, reducing the chance of starvations. So the another slide is about the traditional UNIX scheduling. Finally, traditional UNIX system use a multi-level feedback queue scheduling algorithm. This method dynamically adjusts the proper priority of processes based on their behavior and CPU usage. Processes that use more CPU time are more to lower priority queues, while those that use less and have been waiting longer are moved to higher priority queues. This approach ensures that interactive and short running processes get quick response times, while longer CPU intensive processes are still handled efficiently.
Hello, my name is Isha. My student ID is 20239329. Today my topic is on the basis of group assessment of ICT 104 on the topic of concurrency, mutual exclusion, synchronization. Concurrency is computing allows multiple processes or threads to execute simultaneously, which can enhance system performance. However, concurrency also introduces challenges such as race conditions. A race condition occurs when the outcome of a process depends on the time of other processes, potentially leading to unpredictable and undesirable results. To address these challenges and the concept of mutual undesirable results to address these challenges, the concept of mutual exclusion is used. Mutual exclusion ensures that only one process or thread can access a shared resource or a critical section of code at any given time, preventing conflicts and ensuring smooth operation. Effective synchronization mechanisms such as logs, semaphores, and monitors are essential to achieving mutual exclusion and ensuring that concurrent processes run without causing errors or inconsistencies in the system. And the second topic is about the concurrency deadlock and the starvation in computing. In concurrent computing, deadlock is a scenario when multiple processes are not being able to continue as one is waiting for the another to release the resources. The four essential conditions which must be available for the deadlock are mutual exclusion, hold and wait, no preemption, and circular wait. On the other hand, when a process is consistently denied resources due to existing scheduling policies, the prevention of the deadlock requires a meticulous distribution of the resource according to the current state of the system, and after that, to ensure that the system does not enter any condition that is unsafe for the system, which resultantly occurs a deadlock. Identification of cycles in the resource allocation graph and the observation of resources allocation are involved in a deadlock detection that signify a deadlock. Then some corrective measures such as resources preemption or processes termination can be implemented. The third one is memory management and the virtual memory. Memory management is crucial and critical to improve the performance of computer system. There are some essential requirements that involve the allocation and delocation of memory spaces to protect memory space and from the memory space from the access that is unauthorized, enabling the memory among various processes like ensuring the logical and physical organization of memory for optimal access and utilization. Memory partitioning techniques can be first divided into fixed and dynamic partitioning. Fixed partitioning includes the division of memory and into predefined blocks that can result in an internet fragmentation if the process does not use its allocated block. However, dynamic partitioning divides memory on the basis of the size of the processes that decreases the internet fragmentation but can lead to the external fragmentation and leaving the free memory that's scattered in tiny segments throughout the system. Thank you so much.
Hi, my name is Puneet. I'm going to discuss basic concept of file and file system. Files are fundamental building blocks of data storage within a computer system. And moving on, file system is a crucial component for operational system as it controls how data being saved, arranged from storage devices like hard disks and SSDs. Uh, Moving on, access techniques. There are two types of access techniques such as direct access and sequential access. In direct access, we can randomly enter points within a file for reading and writing, and in sequential, we have uh, which process data in a linear order. And there is B trees, also known for self-balancing trees. They are frequently used in file system for effective data indexing and retrieval. Lastly, there file system and security design issues. File system is system security is a crucial aspect of system design, which is protect against data from loss, corruption, and unauthorized access. To regulate who can read write, there are some strong permission models and access control methods into place. Thank you. In this slide, I'm going to talk about input output management and disk scheduling. Key categories of input output devices and organizations. Input output devices are classified into three main categories: network, character, and block. If I talk about block devices, data in this store data in fixed sized blocks for random access are hard drives and solid state drives. Moving on, device drivers. Device drivers are used by operating systems to organize input-output tasks. They act like a bridge between the hardware and the OS. Uh, Moving on, magnetic disk management and disk scheduling. Operating system involves magnetic disk management to maximize data throughout disk throughout out, and optimize access time. Disk scheduling methods such as first come first serve, shortest seek time first, are used to minimize seek time of read write operations. Lastly, by spreading data across several RAID uh, levels, including RAID 0, 1, and 5, improve data reliability and performance. Uh, and the cache, uh, which improves the performance by storing frequently accessed data in a faster memory location. Thank you.
Hi, my name is Aryan Makkad, and today I'm going to talk about a comprehensive evolution about the operating system security. So, operating system security is very important for protecting computing environments from various threats, including intruders, malicious software, and unauthorized access. So, intruders seek to gain unauthorized access to system, often exploiting vulnerabilities such as weak passwords or unpatched software. Malicious software or malware encompasses viruses, worms, trojans, and ransomware, which can compromise system integrity, steal data, or disrupt operations. So, the second one is authentication mechanisms such as passwords, biometric, and multi-factor authentications are very essential for verifying user identities and preventing unauthorized access. And the third one is access control further that strengthens security by defining what authenticated users can do with the system, employing models like DAC and role-based access control RBAC. And at last, firewall act as a barrier between trusted and untrusted networks, filtering traffic based on the predefined security rules, buffer outflow attacks, where attackers exploit vulnerabilities to execute arbitrary code, pose significant risk, and often leading to system crashes or unauthorized access. So, in this slide, we will talk about the recommendations for enterprise environments that require robust security and scalability. So, Linux is ideal due to its flexibility, strong community support, and advanced security features such as SE Linux. And the second, Windows servers is recommended for organizations that rely on Microsoft ecosystems, offering seamless integration with Active Directory and enterprise software for mobile and embedded systems. And Android excels with its open source nature with wide developer support. Mac OS is always best suited for creative professionals and industries prioritizing user experience and integration with Apple hardware. So finally, Unix is optimal for academic and research institutions that needing high performance computing and scalability. Each OS should be selected based on specific industry needs and target audience. So in this slide, we will talk about the conclusion. And firstly, in order to safeguard dangers like malware, vulnerabilities, and intruders, one must have a good understanding of operating systems, internal workings, and security measures. Secondly, every operating system, including Linux, Windows Server, Mac OS, Android, and Unix, has unique advantages that are appropriate for different use cases and sectors. And in order to fulfill industry standards and guarantee system resilience against cyber attacks and also some malware attacks, so choosing the appropriate operating system based on these qualities is very important. And third, the information is essential for upholding safe and effective computer environments in a variety of industries. And at the end, I will just say thank you.